One day in your career or in life, you're going to have a situation when a car doesn't start you're working on, it has no spark. Is it a coil? Is it a module? Is it a picker coil? Understanding the conventional ignition primary circuit is important to diagnose that vehicle. Because I had been in a situation, I'm thinking all that. I thought it was a coil, picker coil, module. It wasn't either one. It was a bad coil wire. So hopefully understanding and going through this situation, going through these slides will give you more information on how to diagnose a no start by understanding the primary ignition circuit. Here, what we have now is a basic old school point system. We have the battery, ignition switch, coil, the old type distributor, and points. Vacuum advance will help control the timing under driving conditions. Coil wire up to the distributor cap, the rotor, spark plug wires, and spark plugs. Now let's talk about the primary ignition circuit. The primary ignition coil has two sets of windings around the iron core, soft iron core. Voltage and current is going through this balanced resistor while the car is running. It's flowing to the negative side of the coil on the primary windings and comes out at this end. It continues to the distributor when it sees the points, when it's attached to the points. This gap right here is the opening and closing of the ground circuit for the coil. When the points are closed, the coil charges up. When the points open up, the coil collapses and a magnetic field surrounding the coil windings collapse and self-induct into the secondary windings, mutual induction. So it's going to basically take in low voltage and high current, turn it into high voltage, low current. We're going to have voltage coming out this coil wire, it's the secondary side, up into the distributor cap. When the voltage, as every time it spikes, rises this rotor and distributes spark to each individual cylinder to the plugs. Basic ignition circuit, primary ignition circuit. Now, when the car is cranking, we literally bypass this transistor and current, since because of low battery voltage, because it's cranking, and goes this way to the coil and does the same and goes through the same process while the car is cranking to get it going. So we actually bypass this resistor. You ever come across a situation, I have seen this in some older cars, that you hold the key in the crank position to run and you let it go and die out? You have a situation like that on older cars? Check the balance resistor. Because when you let the key go, all the current and voltage travels this way. While you're cranking and you're in the crank mode, we bypass the resistor, it's going this way. So anyway, other thing I need you to remember is the points is the ground for the circuit. Now, this is a lot of moving parts in here. Every time this cam load rotates, right, when you crank the car over, this cam rotates, it's going to open and close a set of points, which makes and breaks the ground circuit. Now this is how it looks on an oscilloscope. This is your primary ignition, conventional primary ignition circuit. It's a waveform. You'll see this on an oscilloscope or a lab scope. Number one is battery voltage. Key on, engine off, we will have battery voltage up here to the negative side of the coil come from the positive end, because it goes through the coil windings and sits here. As long as the points are open, key on, engine off, I'm going to have battery voltage, which is this. This represents my battery voltage. 12.6 volts. Key engine on. Now you start the car up and the points close. I'm going to pull this voltage to ground, like a voltage drop. I'm going to pull it to ground. This section here is your dwell section. This is when the ignition coil is being charged up, getting ready to fire the primary ignition so it can self-induct into the secondary ignition. So this right here, battery voltage, the points close, I charge the primary circuit up. Here, this is my dwell section. They call it the dwell section. This is when the coil is being charged. And now, keep in mind the car is running right now. Number 3 is when the points, again, open. Once it opens, I got this primary kick, spike. Once I receive this spike, because this actually mirrors itself into the secondary, I have a spark line. This is your spark line here. This is how long the energy lasts across the spark plugs. Technically, you can actually watch this line. This is your eyes inside the cylinder. I can tell I got a shorter plug, an arcing wire, or even an open wire by watching this fire line, which is in the secondary. This would be the fire line, and this spark line. Next thing is the coil energy after it dissipates. After a fire, this is dissipating energy. You see right here, I didn't mention it, but it's the condenser. We had to get rid of that excessive energy to protect the points. This is the dissipating energy right here. The oscillation of energy back and forth from the coil to the condenser. This is a amp probe. Okay, it's another way to look at your secondary ignition circuit. I'm looking at this amperage circuit. It's not voltage now. Now we're on an amp probe. Down here is 0. Okay, this is the amperage rising when the coil is being saturated. It's being charged. Right here, we're at 0. Okay, start off at 0. 0 volts there. This ramp here is when the coil starts to charge. Okay, so in other words, this is when you got system voltage, 12 volts, and the points are open. All right. Remember, we're looking at current. This is the current now, not the voltage. If I go back, let me see. If I go back here, this is the points are open. This is the open section here for the points. No current is flowing. Remember Ohm's law. There's no current flowing in the open circuit. Right here, it's an open circuit. No current is flowing. At this point here, when it's pulled down the ground, current is start to flow. I'm charging the coil. By looking at the current, I can see the current going through the coil. This ringing here is current encountering resistance. You want to see this ringing. But I tell you what, all cars don't ring like this. Okay? The main thing you want to look for is the ramp. You want to see this ramp on a slant like you're seeing now. If this would go up and ramp, in other words, I don't encounter no resistance here with the oscillations or not. If you just go straight up, then it ramps, you got a shorter coil. Now, I have seen coils ohm out good on the bench, but you do this test here, it comes out bad. And usually what happens in a situation like this, the coil will misfire under a load. Up here is the amount of current that's flowing through that coil. You can have anywhere from 5 to 9 amps going through that coil. That's why it's good to take known good pictures of different coils or different manufacturer vehicles. Alright, different ignition setups, I should say. Okay, because too much current can actually damage a module on some of the newer cars, the computer. This is now number 5 here is after it fired. Remember, when it fires, the points open up. When the points open up, it goes back down to 0 and repeats itself again. Now, here is the HEI circuit after a set of points. We have right here is the vacuum advance and centrifugal weights. Both these things, this will work off a vacuum. We advance the timing by pulling the breaker. by pulling the breaker plate to advance the timing. This is centrifugal advance. This is RPM speed. Both these components help advance the timing under certain driving conditions. Now besides that, what you see in here is the ignition module. Inside this module is a transistor. It takes away the points, less moving parts. But inside is a set of points called a transistor. And it works the same way as a set of points. The only difference is when the cam rotates, this is the pickle coil. When it rotates, I'm sending an AC signal into the module to trigger the transistor. Let me show you. Here's a transistor. It's an NPN transistor. Positive voltage is given to the collector. Here's the collector. Here's the emitter. So positive voltage is given to the collector terminal and current flows from the collector to the emitter as you see over here. So my voltage, this is my source of voltage. Here's the load, which is the coil. So I got voltage going to the coil like we showed you earlier, coming out the coil. Remember, this is the coil. Use your imagination. This is the ignition coil. Coming out the coil on the negative side. This is the positive side. So voltage going into the positive side, going through the coil out the negative side. The wire from the negative side goes into the module. The module has the collector, the little transistor. This right here, it's your set of points. So go through the collector, through the base, through the emitter to ground. When the emitter is closed, like a set of points, we're charging up the coil, primary side of the coil, primary side of the windings. But before the transistor can work, we need a signal on the base. The base controls the operation of the transistor. We need a positive voltage on the base. It could be a pickle coil, but most likely it's a digital signal. If it's a pickle coil, it will rotate as an AC signal as you've seen earlier. On the positive side, it will engage it. On the negative side, it will disengage it. But it's going to be converted over to a digital signal. If it's a digital signal, I just have a square wave going in to the transistor through the base. On the positive end, I engage it. On the falling edge, on the negative side, I disengage it. When I say engage and disengage, I mean this. When I have a positive side on the base, current flows from the collector through the base to the emitter to ground. I charge the coil. When I have a negative on the base, I remove the connection between the collector and the emitter. I don't charge I have no ground. The magnetic field collapses and I have spark. That's the key element I want you to understand. You have spark when you having spark, or trigger I should say, when this ground at the emitter opens and closes. But only opens and closes with a trigger from the base of the transistor. I'm going to explain that to you in a second. I don't see many of these, but this can happen also. It's a PNP transistor. A positive voltage is given to the emitter, which is this one, right? Terminal, and current flows from the emitter to the collector. So now I got current going from the emitter to the base to the collector. The only difference now is this. This is complete on the negative end and turned off on the positive end. I can't recall any car that uses this. I'm pretty sure it is. I just can't think of it. You can see it also has a resistor in series to it also. Now here's the module. Now look at this. This transistor you see here is internally in here. So relay internally. Let's say WG. It used to say P and N. I don't know what WG comes from, right? This positive, negative. This is coming from a pickle coil inside the distributor. Okay, that's coming from inside the distributor. It's a pickle coil inside the distributor. As it rotates, which is a permanent magnet, we learned about that earlier. It's a permanent magnet, right? It's reducing the AC positive, negative signal into the module. And that's going here to the base. That positive negative signal is going to be converted to a digital signal. Now keep that in mind. Now let's go over here real quick. Over here for the ignition switch, we have power to turn the ignition module on. We have power to the coil, remember? So voltage is flowing through the coil. And when I have no ground, I have potential voltage here, waiting for a ground. When I get a signal here at the base, I complete my circuit to ground, and my voltage here, it gets pulled down to ground. And I'm saturating the coil. When I lose my voltage at the base, I lose my ground here. And I get sparked out to the distributor that feeds the spark plugs, the wire to the spark plugs, through the cap, rotor, spark plug wires to the plugs. So, with that said, if I take a test light and ground it and put it here, I should see that test light blink, indicating that my transistor is working. So I had a car with no spark, and I want to know if my input side is working. I'll put a test light here and see if it blinks. If it blinks, that's telling me my module, transistor, coil, and pickup coil inside here are all working. And my problem, if I had no spark, is either a coil or coil wire. This coil wire does go bad. It got me like that one time. Back in the day, I thought, it had no spark. I changed the module, I changed the pickup coil, and I changed the coil. It should start up, put all three in, no spark. Make a long story short, the customer said, hey, how about this wire? The customer said, how about this wire? I said, nah, that wire never goes bad. So I ordered another module, I ordered another pickup coil, still no spark. The customer again said, why don't you try the wire? I said, okay, I'm gonna show you the wire doesn't go bad. I put another wire in here, and the damn thing started up. Embarrassing moment. I don't know how we took care of that. We get a customer cost of the parts, so I gave it to them for free. I don't know how we fixed that problem. But that wire does go bad. Now, here's the pickup coil again. Here's the setup again. Look at this. Here's the distributor. Here's the pickup coil. Here's the module with the transistor in it. Okay? You see the side right here? This is connected to the pickup coil. This is my battery voltage over here and other connections for the 4-wire connector. Let's concentrate on this piece here. As this reluctor rotates, an AC signal goes into these two wires, this green and yellow wire, into the module. That's this picture over here. This AC signal goes into the module. It's going to be converted to an AC to DC converter. It's going to go in AC, come out a digital signal square wave. It's going to come out like this. When we're cranking the car over, I'm going to have an RPM signal going through this wire, up here through the R terminal of the module, which is over here. I'll turn into the module, into the PCM. But at the same time, I'm going to have a signal going from here. Remember, because we're cranking the car over, we got to start it. At the same time, this same signal is going to go this way to this relay to trigger the base of the transistor. So we can have spark while we're cranking the car over. So that's positive here. Remember that? I need a positive signal to the base of the transistor. That's going this way to the transistor. But back over here, I get an RPM signal in the computer know the car is cranking. Once I see that, the computer's gonna send a 5-volt bypass out. You gotta go check the timing for spark or engine performance. You're gonna say disconnect the black wire brown tracer or 4-wire connector, because you're disconnecting this bypass wire. This 5 volts is gonna be delivered to this wire, to this coil, to ground, like a relay. I'm gonna switch from cranking mode to running mode. When I switch that way, now my PCM is going to send a signal out the EST circuit for electronic spark timing to control the timing under different driving conditions. And that's going to go to the base of the transistor to trigger the module. It's called my EST circuit, electronic spark control. As you see here, I have my battery voltage, configuration switch, R relay. I have my picker coil, positive, negative. I used to, back in the day, I called this P-NURB. Positive, negative, EST, RPM, bypass. P-NURB. Anyway, I have my picker coil signal going here. My AC signal is going on to the converter and it's coming out. You can see here, this is a much clearer picture. You can see here, I have a digital signal going here to the base. Once I get a positive signal on the base, I'm going to, from the collector to the emitter to ground, trigger the coil. See right here? This is going to the coil negative side. I'm going to trigger the coil. But once the car starts, once the PCM sees an RPM right here, this is my RPM signal. Going back to this, letting the computer know, use a purple wire on GMs, and letting the computer know that the car is cranking. So we're going to send a 5-volt bypass out to here, and now we're going to switch from cranking mode to bypass mode. I'm going to switch this connector like a relay. So now the PC is going to control the timing through the EST circuit, which is E. I think this arrow is going the wrong direction. Right? From this EST circuit, it's going through here to the base of the transistor now to control the timing at different load situations. Again, the same way. A positive signal here, I complete the ground from the collector to the base to ground. A negative signal here, current does not flow and the coil fires. That's your circuit. Understanding this circuit will help you troubleshoot a no start condition with no spark. If you have any questions, please let me know. Peace. I'm out.